Okay, so we're going to resume the general track now, and we have a talk from Deepyaman about Python is all you need, an overview of the composable Python native data stack. So without any further ado, we'll let you take it away.
All right. Welcome. Good afternoon. My name is Deepyaman, and today I'm going to talk to you about the composable Python native data stack. Now, don't worry, we'll go through what each of these words mean. I'm very excited to have the opportunity to give this talk at SciPy. It comprised work that I and others have been doing over the past many years, and a realistic vision for the future of Python-first data engineering. As a data practitioner who lives and breathes Python, but also understands its limitations, it's very personal to me. So first off, why should you care? So I'm sure that there are maybe a data engineer or two out there in the audience, but the majority of people at SciPy are probably coming from more of a AI, ML, just some other science sort of angle. So maybe you came here because of this super creative title. I think it's actually been like maybe 3 weeks since there's been like a all you need paper published on archives, so very unique. Actually, speaking of landmark papers published on June 12th of 2017, I learned this while I was preparing the presentation. You may have seen some form of this image before. So this comes from Monica Ragati's 2017 article entitled The AI Hierarchy of Needs. So believe it or not, it was just published on the exact same day as the first version of the Attention is All You Need paper. So what this basically shows is data scientists want to spend most of their time doing the things which are at the top of this pyramid, the actual kind of like machine learning work. But in reality, you end up spending like 70, 80% of your time on tasks in the lower parts of the pyramid, which are the things like sourcing the data, transforming it, preparing, cleaning, all of these things that fall under the broad swath of data engineering. In your work, maybe you work with a data engineer, maybe even you work with a team of engineers. But for many people, you are also the data engineer. And even for some of these use cases a little bit further up the pyramid, so some of the things like analytics, metrics, and reporting, you probably find yourself, even if you are a data scientist, doing quite a bit of this. A lot of people would also say that this kind of falls under the broad scope of data engineering. Before we introduce the need for a Python native data stack, what is the other data stack? So if you're around and you look back 10 years, what was happening around that time? Cloud transformations were in full swing. Data scientist was the sexiest job of the 21st century, and companies were all trying to do their analytics transformations. Around this time, there was also another big shift happening in the data engineering world. So there had been the advent of several key technologies over the past many years that enabled data engineers to take advantage of the cloud for their workflows. So you can think about Looker, for example. Looker enabled business intelligence, things like building dashboards, directly on top of Amazon Redshift, benefiting from the inherent performance and scale of the cloud database. It seems obvious now, or I mean, actually, maybe it doesn't. In a lot of the Python workflows, you still see this very like kind of pre-modern data stack pattern. But it was a revolutionary idea at that time that you could do business intelligence work without local data processing. This timeline just shows some of those kind of key technologies, including the cloud databases, some of the BI tools, and kind of finally also things like your ingestion tools and transformation tools like dbt. We'll talk more about this all later. Okay. So ELT and ETL. What's the difference here? So with the cloud, that meant that ETL could be rebuilt as ELT. So imagine you are ingesting data from some external data source. So let's suppose something like Salesforce. In ETL, you extract data from your source system. You transform that data externally, and then you load that into your place where you're going to be doing analytics, like your data warehouse. So you really think about like, okay, how do I want this transformation? In contrast, like with ELT, life's arguably much simpler. You just need to land your data from your source system into your cloud data warehouse, and then you can transform it after the fact, utilizing the fact that you have the cloud computing power of your database. So this takes us to the modern data stack as we know it. This idea, you can see here, it took off. dbt in particular was a huge part of it. It became the standard for data transformation using SQL in the cloud. Together, modern data stack tooling became the way to data engineering work. As an aside, it's also so prevalent nowadays that people like Tristan Handy, who originally coined the term modern data stack and is also the CEO of dbt Labs, don't even want to call it the modern data stack anymore. They'd rather just simply call it the data stack or analytics stack. So when we talk about it in the Python sense, we're not going to talk about it as the Python modern data stack. It's also a mouthful to say. So where were we in all of this? So we've been talking about SQL all this time at a Python conference. So let's get to it. As you know, like Python's exploded in popularity during this time period as well, especially given the rise of AI and ML and its application to scientific use cases. However, Python was never really a first-class citizen in the modern data stack. It had some support, but it was kind of more of a after-the-fact thought. Capitalizing on developer interest, it's there, but it's usually insufficient or incomplete. And it's more of this fallback option for when you can't do something with SQL. So especially if you think about like kind of complex transformations for machine learning or something that you can't represent in the database. I should caveat the last point on this slide, that Python first data pipelines couldn't scale. Spark was a thing, is a thing, PySpark is a thing, Databricks was and is successful. Dask is also a thing. It hasn't really taken off in the data engineering world per se, but these kind of options are there. But if you ask most data engineers, and by which I mean if you go and look on the data engineering subreddit, Python is slow and it doesn't scale. Looking at this graphic real quick, I just like the fact that GitHub doesn't even consider SQL a programming language. If you look at the Stack Overflow developer survey, it provides a bit more of a nuanced view. SQL is right up there with Python. Some of the JavaScript stuff is more common, but this shows just a general trend of things. All right, so talking about scale. Just a quick show of hands, like how many people have heard of Ibis? Okay, that's actually more than I expected. So Sci-Fi is an event where there's been a number of talks about Ibis over the years, and more people are aware of it than I would have even thought kind of going into it. I expected to be more at Sci-Fi. We also gave a tutorial like a couple of days ago on using Ibis for end-to-end analytics. Maybe you saw it then, but it seems a lot of you already know it. Basically, Ibis, as many of you know, provides a familiar data frame API. Think something like pandas or polars if you're coming from like the R side of things, like dplyr. The main difference is unlike pandas and more like polars or lazy frames or PySpark data frames. If you're familiar with those, Ibis has a deferred execution model. In short, what that means is compute occurs when it needs to, as opposed to when code is run. On top of that, Ibis is interfaced to all these query models. Query backends, so things like BigQuery, Snowflake, Data, DuckDB, and Polars locally. In most of these cases, right now everything except for Polars, this compiles to SQL. So put another way, Ibis performance is indistinguishable from SQL performance at scale because Ibis produces SQL. In a way, you can actually say that Ibis pushes language interoperability to the next level. I won't harp on this point too much. There have been some great presentations, maybe you saw something here, like by Gil and others, that showcase how for some queries like more simple than the one that we have on the screen here, that there could be a range of different SQL translations for the single equivalent Ibis code. So more than just an interface, Ibis is also a unifying standard. So let's talk about the fundamental components of a data stack. So the data engineering lifecycle comprises a number of stages, from generation to consumption, and many steps in between. In particular, we're going to focus on 5 core components as laid out by some IBM article I read. You'll notice the components here closely mirror those that were a few slides back. The one thing that we've added here is data observability, which you can think about as like data quality, data validation. We'll go through each of these pieces one by one as we talk about the Python analytics stack. So first up, the storage layer. This is more of a cross-cutting concern, and it's also not something we're going to spend a lot of time explicitly discussing, given it's something we inherently get for free with Ibis. Data storage can take several forms. It could be data warehouses, file formats, your newfangled lake houses, which are essentially files with additional metadata. Ibis supports them all to some extent. Support for things like Iceberg is a bit more backend dependent. One thing to keep in mind with Ibis is that it defers to the backend whenever there's like a better, more efficient path available. So think Spark with Iceberg, for example. But it also won't do things poorly or strives not to do things poorly. If something's not well supported, Ibis may not support it. PyIceberg exists for interfacing with Iceberg, but it has some limitations. So Iceberg support is one which is still forthcoming more natively in Ibis for across backends. Next, let's talk about data ingestion. How do you get your data from your sources to wherever you're going to actually do the analytics? I'm not going to spend too much time on this either. And that's not because there's not a good solution. It's actually the opposite. It's because it doesn't really require much justification for a Python solution. DLT is already the choice, a tool of choice in the modern data stack. It's Python first. It's built on top of taking advantage of a lot of open standards like Apache Arrow. It has integration with Ibis. It's just really a natural choice. Instead, we can just jump right into a simple demo. This is like a quick example of what a DLT pipeline might look like. But let's look at one which we can actually check out here. So we just name it file system pipeline. We're going to be working with, if you're at all familiar with DBT or if you've heard of the Jaffle shop, we're going to basically be replicating an example similar to that. If you haven't, that's also fine. Basically, you can see here we've got our customer order payment data that exists in whatever's our source system. In this case, it's CSV files. And we're going to ingest them into a DuckDB destination. We can just go ahead and run this ingestion script using DLT. DLT is lightweight, Python, you can run it wherever. And then I can we can go ahead and take a look at some of our results. So let's see, Ibis DuckDB. And we've ingested into a database entitled jaffleshop.duckdb. Should assign a connection, and we can take a look at the tables in there. So we see some DLT metadata tables, but also our raw customer, raw order, and raw payment data. If we decide to look at one of these, let's go ahead and set interactive mode so we can see, and then let's look at the orders table maybe. Whoops. Problem with live demos sometimes. You forget the syntax. So anyway, we look at the table for all orders. Data looks reasonable. Okay. So that's our ingestion piece. So next up, let's talk about data transformation layer. So this is where it all kind of began when we're also talking about the Python, with the Python equivalent of the modern data stack. So given DBT's central role in the modern data stack, this is something we really need to get right. The great news is that Kedro fits perfectly here. This is a quote here from Cody Peterson. He used to be at DBT Labs and actually led some of the work supporting Python models for DBT, and later was a PM at the Ibis team. But essentially, based on his experience, Kedro and DBT look very alike in their goals and approaches. Just one is more catered and built by data analyst personas, and the other by your data scientist persona. So what is Kedro? Kedro is an open source Python framework that applies software engineering principles to data science and data engineering code. So even taking a brief detour from this, do you care about reproducible science? If so, I think you should be aware of Kedro. Kedro structures logic in pipelines, or DAGs, directed acyclic graphs. The nodes in the DAG are just vanilla Python functions, and that makes Kedro very flexible. One of the most beloved features of Kedro is the data catalog. That allows you to specify for each of your data sets, how does Kedro load and save inputs and outputs from a node? This is where we introduce our explicit Ibis support. By adding a data set, actually two, an Ibis table data set, Ibis file data set, that allow reading and writing Ibis tables, we can support whatever backends Ibis supports. Since nodes are just Python functions, Ibis dataframe manipulation code just goes into nodes. A couple of other benefits. So Kedro is extensible by design through hooks. MLflow is actually the most widely used integration, but you also have integrations with other parts of the data stack. Things like Kedro and Pandera, we'll talk about that a bit, and Airflow for orchestration. And last but not least, I think it's very important to mention that Kedro is a foundation-managed open source project with a diverse technical steering committee. While Kedro came out of Quantum Black Labs, which is part of McKinsey, the maintainers are now people who, like myself, are a lot of them are unaffiliated with McKinsey. We have other maintainers also from like Societe Generale and Palantir, ING Bank, healthcare startup, Astronomer, Printify. It's a very diverse TC. I think about half of the people are not affiliated at this time with McKinsey in any way. We're committed to basically making Kedro the standard for data transformation in Python and for building reproducible data pipelines the best way. Okay, let's just highlight real quickly like one of the benefits of using Python and like something like Kedro and Ibis compared to DBT. So one of the things is you end up with kind of like this more consistent, nice, testable way of expressing your logic in Python. So we can see that with SQL, you might have to do things with Jinja, which is essentially like applying some of that power of Python inside of SQL. Instead, here we can do everything in Python, kind of more Pythonically. We can open up like let's look at a pipeline here for data processing. And if we look at the nodes, it's kind of a broader example of something that takes a couple of tables, orders, payments, takes some parameters around your payment methods, and it creates our like kind of more final table for orders. If I go ahead and run that pipeline, that looks like it worked. We see that it saved data to a table named orders, and I can again do, let's see, import Ibis. Okay, and now if I look at our orders table, for example, yeah, it looks like we have kind of our just created table from running the stag. There are a lot of other features of Kedro I'm not going to go into. Could spend a lot of time on this. With that, let's actually kind of just move on to the next piece. So that's going to be data validation. Ensuring data quality is an important activity in production data engineering, but honestly, anytime you're working with data, garbage in, garbage out, right? You may have heard of Pandera. It's a popular lightweight Python framework for validating data frames. Niels, the creator, he's spoken about it at SciPy at least once or twice, I think first in 2020, and then he talked about how support expanded beyond Pandas data frames in 2023. We're going to take it to the next level here by adding validation of Ibis tables. This is really new stuff. It came out in version 0.25.0, which was released yesterday, but it's something that I've been working on for almost 2 years now. All the standard functionality you want, from built-in checks, ability to find custom checks, integrations with various tools across the ecosystem are all there. One of the key benefits in my mind of Pandera is that it's a lightweight library that you can use anywhere. Contrast this to some of your data quality frameworks where, yeah, data quality becomes like your first class concern, but for a lot of people, you really care about your logic, and then you want your data quality to be good. You don't want to be thinking about everything in terms of data quality. So with Pandera, you can just really use it wherever you want. We have a quick example of Pandera schema validation. You can write things a number of different ways. You can actually go ahead and open this up here too. So if I look at our Pandera example, you'll see we have like a custom check, which is looking at whether our total amount for each of our for each of our orders is going to be greater than 0. We're going to also take a look at just some of the data types, as well as validating like, oh, what are the values within for like a string categorical column. I can run this on our data that's already in the database. Everything there should be fine. But if we go ahead and like introduce an issue, right? Like here we're going to introduce something where for a certain order it'll be negative. We can see what kind of an issue this will raise. This raises that, okay, that total amount, -50, is failing, right? So that all makes sense. All right. So the final layer of the analytics stack we're going to cover briefly is BI analytics. The easy side, believe it or not, is the ML work. That's because Python can be used for data engineering, right? And working with databases, but it's also great for doing machine learning work. On the other hand, SQL, it can't be really used for ML stuff much. So if you care about data engineering for ML use cases, one of the things that you might love about this is you can use the same framework, so things like Kedro, across your data lifecycle. A lot of the data analytics use cases will also involve creating data visualization dashboards. So I'm going to be upfront and mention that I'm not an expert on this. Ibis does support integration with a wide variety of visualization libraries, things like Plot9, Altair, Matplotlib, Seaborn, I think Plotly as well. There's a list on the Ibis documentation. For some of them in particular, so things like Streamlit, in that case, it supports like kind of a deeper integration. It supports the Streamlit connection interface by which you can kind of efficiently interchange data with Streamlit. Last but not least, and this was something I was learning more about yesterday, Shiny can also be a great option. It inherently supports a lot of these libraries that mentioned here, and it's also a very powerful dashboarding tool. A lot of the teams here, you can talk to them if you're curious. It's something that I also hope to have like a bigger, kind of deeper understanding of this picture and what really works well at scale over time. Okay, so this kind of brings us to wrapping up. What are some of the kind of gaps, limitations to be aware of? Well, one is, in general, some of these technologies are still new or maturing. It's good for a lot of things. Ibis doesn't have right now upsert support. This is something that I think that there's a pretty clear path towards adding. It's just more a question of time. Also, a lot of the community integrations are maturing. So, for example, Kedro Pandera was kind of developed in an early version, hoping to kind of like help pick up on this sort of work. Also, integrations with orchestrators. So, integration with things like Kedro and Airflow that does exist. It's widely used. It's maintained by the Kedro team itself. But I think that there are opportunities to always improve, do things better, make things a little bit more data native. Airflow 3 came out native recently, and there's some kind of great opportunities to create a better orchestration experience. Other integrations are always possible, things like Open Lineage, if you're familiar with data engineering, kind of like Lineage, well, both for data, also for ML, sort of workloads is something that people care about a lot. The last piece is the awareness. I think sci-fi community here, a lot of you are aware of Ibis and some of these other technologies, which is really great. More broadly, people know, like everybody knows about pandas, polars, especially from the data scientist side. How many people know about this is probably less. So of course, like I think it's quite useful, and there's just that gap of kind of people becoming more aware of it. So last but not least, why does this all work? So I think one is it was built organically to solve like real problems. I myself did a lot of Python-oriented data engineering and saw a lot of kind of bad practices there. A lot of other people, somebody else was actually the first person I saw kind of looking to integrate Ibis with Kedro, and it started from there with things like Pandera. I think I was learning yesterday that when Niels was here giving a talk on Pandera, it just came up with somebody from the Ibis team that, oh, maybe this would be a good fit. It was something then that I just kind of also came across and decided to take on. We talked a little bit about the benefits of unified Python tooling, especially if you're doing things across data engineering and machine learning. A lot of these tools picked here also have very solid fundamentals. They're really grounded in the principles of like composable open standards. And yeah, you can really view here Python as a foundation for the stack, not just being kind of like, a fallback option for when you can't do things with SQL. A lot of this is based on kind of work across the community as well. So where can you learn more? We talked about a lot of these different tools. Here's some links to documentation. You're welcome to take a look at these. There's also the demo, some of the stuff which I showed here, which you can dive more into, as well as like some blog articles on integrations between Kedro and Ibis. She gave a tutorial on this at PyData London last year. And finally, if you are curious more about the internals, like especially, can Ibis really be equivalent to and as good as SQL? I did write a blog article earlier this year around what's the level of SQL understanding of Ibis. And well, long story short is it understands this quite deeply using some underlying frameworks. That's all I have. So I appreciate your all time.
All right, thanks very much. We definitely have time for questions, so if you have any, please drop them in reply to in the Track General channel. So we've got a question from Jay, who asks, DBT has some key features like the automatic documentation with metadata, lineage, etc. Does this stack have a solution for that yet?
Yeah. So in terms of like automatically documenting your data models, so some of the things that Kedro does have is it has your visualization of your DAGs. It also has that extension mechanism through hooks, which are kind of based on top of like pluggy hooks, where if you want to do kind of additional documentation based on those nodes, it's quite simple, like let's say a node docstring, and like if you want to write out additional kind of metadata for some of these, it's possible to do. With some of the other pieces like lineage, I'd say that these are not, so like open lineage integration with Kedro, there's like a POC for that. Lineage from Ibis is something that's come up several times. Again, one of those things where somebody needs to sit down, tackle it. Since it uses SQL Cloud under the hood, it would be quite simple to do it, but some of these integrations just don't exist yet. So it's just really tackling these one by one or parallelizing them across the community.
Okay, great. All right, Jay has a follow-up, but I'm going to exert share privilege and ask mine. So you mentioned a little bit about reproducibility, and you also mentioned that there was some integration with ML flow. So can you talk a little bit more about what reproducibility means here and the relationship with ML flow, if it's built as an extension or if it's built on top of, et cetera?
Yeah, so first I can talk just more broadly about reproducibility. So Kedro was built out of the fact of, okay, a lot of people, especially if you're thinking from a data scientist perspective, maybe you have a lot of just notebooks. There have been people also giving talks on like, moving things out of notebooks into Python packages and structured functions that you're calling in a sequence. Kedro for many years now has just really had a very formalized, proven out approach of doing this. It builds out your DAG. It can more efficiently like run things in parallel and so on. And the main thing is that, yeah, if you want to go and update some parameter, you can just go run again. You can run from a certain part of the pipeline. You can change your configuration between like an environment from dev to prod without having to be like, which set of things do I run one after the other? So it provides like a way of more formalizing your workflows, bringing software engineering practices. There's also ML flow and like things like native experiment tracking, run tracking, things like that. Kedro so this is built as an external extension. It's maintained by the person mentioned working at Societe Generale, and it's become one of the most widely used integrations for Kedro, and something that always makes sure it's working. So basically that includes things like your model registration, as well as things like you can also do things like run tracking with ML flow.
Okay, great. So I think we have, maybe time for a very, very quick question, because then we're going to have to stop. So, Yeah, we have one from Ali. So where is the data processing itself occurring when using Kedro, and is that configurable?
So the question is, where is the data processing occurring?
Yeah.
Okay. So it really depends on how your logic and your Kedro nodes is written in a way. So part of the thing with Ibis is that, so Ibis is something you can run locally, but then the actual processing will occur wherever your data exists. Similarly, you can do things with like PySpark and so on also, where you're configuring for it to run in a cluster. But otherwise, your logic is essentially running where Kedro is running. And you want to, especially if you're working at scale, you want to minimize the amount of data that you're actually bringing into that environment where Kedro is running. So in short, it's going to mirror your underlying Python code. Kedro isn't doing anything particularly smart about that, but you can be smart about like some of the libraries and tools that you use under the hood if you are working with data at scale.
Okay, great. So we have a few more kind of questions that are in there. So if you could, if you've got time, if you could follow up in the Slack thread, that'd be fantastic. But let's thank our speaker once again for a great talk.
Thank you.